In today's video, we're going to be looking at similar triangles and proving they are similar, and also determining the sides of similar triangles. So in order to prove if triangles are similar, we have to show that they have the same shape but not the same size. So meaning that they're going to have the same angle measures for all three of their angles. All right, and remember, all three angles in a triangle add up to 180 degrees. So if in order to find the missing angle of a triangle, you have to cut out two of the angles from 180 degrees to find the third angle. So if we look at our ABC, we see that to the angles we have two of the angles are 92 and 59 degrees. To figure out the third, what we have to do is 180 minus 92 minus 59, which is 29 degrees. So it's a 92, 59, 29 degree triangle. Same thing here. These actually have the same exact numbers, 92 and 59. We have to do the same thing to figure out the third angle, which is also going to be 29 degrees, since those were the same numbers. So yes, they are similar. This little squiggly line means similar. Because both are 92, 59, 29 degree triangles. So when all three angle measures are the same, they are similar. Okay, now determining the length of the sides is a little different process. When we're determining the lengths of the sides, we know that the sides are proportional with the similar triangles. What do I mean by a proportion? A proportion is when you have two fractions set equal to each other. Okay. Now, in the first one, in B, we're trying to determine the length of AC, A prime, C prime, excuse me. So A prime, C prime. First, I got to determine where that is. Okay, A prime, C prime is this side right here of this triangle. A prime, C prime. Now, hopefully, or else we wouldn't be able to solve it, you would have to find the similar side on the other triangle. So the similar side is AC. So AC, those are the similar sides of those triangles. We don't know the length of A prime, C prime, so we're going to call that X, and that's going to help us form a proportion. Okay, but we do know AC, which is 6.1. So that's a good thing. All right. Now we have to look at another pair of similar sides that they give us. All right. If we take a look at the triangle, the bigger triangle, we have A prime, B prime, which is 5.12. And let's hope that the other side is similar, AB, which is labeled. AB right here, it is labeled as 3.2. So those are the similar sides. So we know that the similar sides form a proportion. Now you got to be careful in setting up your proportion. So A prime, C prime, that's what we're trying to figure out. That's my X, okay? And again, you can set up these proportions in different ways, but it's really important what goes on the top and what goes on the bottom of your proportion. Let me make this a different color, green. So a proportion is when an equation with two fractions, All right. Now we're trying to determine the length of side A prime, C prime. So I'm going to put that on the top left of my proportion, A prime, C prime. The similar side to A prime, C prime is AC. Now remember our other pair of similar sides. We had let's use this color. Okay. These are similar sides, other pair of similar sides that they give us. Now, it's really important that you label it correctly on the other side. If the prime is on top, okay, that means the prime has to be on top of the other one. So we have to use the 5.12. So the A prime, B prime goes on the top of the other one. And then the side similar to that is just A, B. So it's important, right? When you're putting numbers on the top or on the bottom. So the length of A prime, C prime is X. The length of AC is 6.1. The length of A prime, B prime is 5.12. And the length of AB is 3.2. To solve a proportion, we cross multiply. Cross multiply. So x times 3.2 is 3.2x. 6.1 times 5.12 is 31.232. To solve for x, we divide both sides by 3.2. Now I'll cancel these guys out, and you get 9.76. So that is the length of side A prime, C prime. So again, it's number one, kind of recap, similar triangles have all the same angle measures. And remember, all the angles in a triangle add up to 180 degrees. To figure out the sides, you have to be consistent with the similar sides of the triangles when you're making your proportion. So you set up a proportion, you said two fractions equal to each other. Okay. We made sure that the primes were on top. Okay. And then the similar sides were on the bottom. All right. Because if you flip flop them, you won't get the right answer. Okay. So either primes are on top or primes are on the bottom. Okay. But you have to be consistent with where they go. All right. So if you have questions in class, please let me know. You can determine the length of BC in multiple different ways. We already have our similar side. You could use the similar side we have from before, which was this one right here. Okay. A prime, B prime over AB. Okay. Or you can use a different one since you know that you have a 9.76 as your A prime, C prime. All right. So if you have questions, please let me know in class. Work through these problems and get this finished.